Welcome to 10th class maths lessons. Let's continue the progressions chapter. Okay, this is part 2 of the video. So in this video we will be learning of the geometric progression. Okay, so this is the 6th chapter from the Telangana class 10th maths book, and we will be learning geometric progression in this. Have a look at my previous video for the arithmetic progression and the exercise part of it. So let's get into the chapter. Let's learn the geometric progression. Consider the following patterns. Okay, so there are three patterns given here: 30, 90, 270, 810, and dash dash. 1 by 4, 1 by 16, 1 by 64, 1 by 256, and so on. Okay, 30, 24, 19.2, 15.36, and 12.288. Okay, can you write the next term in the each pattern? Okay, so let's see the pattern first. The pattern here is, if you see here, 30 is multiplied by 3, 90 is multiplied by 3, and 270 is multiplied by 3. So next one should be 810 multiplied by 3, right? Yeah. And here 1 by 4, it is divided by 1 by 4, divided by 1 by 4, okay, divided by 1 by 4 again. So you will get is, what you will get is 1 by 256 into 1 by 4, that is 1 by 1024 is what you will get next term. Okay, similarly here also, in the number 3 also, 30 to 24 is like 30 times 0.8, 24 times 0.8. okay, so each term is basically multiplied by 0.8, and then you get the next term basically. So here it will be 12.288 into 0.8, then you will get the next term. Okay, so if you see here, the difference between arithmetic progression and here, instead of addition, okay, the series is basically the term is basically a product of some constant number to the previous number. Okay, so t of n, if you call term n, is equal to some constant ratio r into t of n minus 1. Okay, so such a list basically where successive terms are obtained by multiplying the preceding term by a fixed number, then such a list is called geometric progression. So the key part is here. Okay, it should be successive terms are obtained by multiplying the preceding term by a fixed number. Okay, t of n equal to t of n minus 1 into r. Okay, then these such lists are called geometric progression. They are in the geometric progression. Okay, and the fixed number is called the common ratio, okay, of GP. Okay, so in the examples here, basically you will see that 3, 1 by 4, and 0.8 are the common ratios. Okay, so this is about the geometric progression. The only difference between arithmetic progression, geometric progression is you have similarly initial term. Okay, in arithmetic progression you obtain the next term by adding a fixed number. Here you will get the next number by multiplying a fixed number. Okay, so obviously how do you define a GP, geometric progression? You should have an initial term, so a cannot be 0 and r cannot be 0. Okay, so these are the basic rules for geometric progression or arithmetic progression. And r is not equal to 1 also, because if r equal to 1, what happens? The series will be a, correct, which is also, you can call it as arithmetic progression also, right? So r also should not be equal to 1. Okay, now the second term will be coming by ar. Okay, r is the common ratio, so a initial term is multiplied by common ratio, that is r, so ar. Third term is ar square. Okay, so the series will be something like this. This is called general form of geometric progression: ar square dash dash dash. Okay, and just like arithmetic progression, here also any consecutive terms, if you divide them, you will get the common ratio. Okay, ar by a, or ar square by ar, which is equal to r. Okay, the preceding term, successive term by preceding term equal to r, basically tn by tn minus 1 equal to r. Okay, or an by an minus 1 equal to r for all values of n. Okay, so now this is what you're trying to tell, an by n minus 1 equal to r. Okay, and r is definitely not equal to 1, that's what we define, and n is a natural number greater than or equal to 2. We should have minimum 2, right, to tell that series. Okay, so let's do this section. Yeah, do it section. Which of the following are not GPs? Okay, geometric progression. 6, 12, 24, 48. So how do you tell if a given series is not in geometric progression? You find the common ratio. If the common ratio is not constant, then you will say that it is not in geometric progression. So here initial term is 6. So a by 2 equal to a2 by a1 is equal to 2, a3 by a2 also 2, a4 by a2 also 2, which means common ratio, you have a constant ratio basically, so common ratio is 2. So that means this series is in geometric progression. Okay, this is in geometric progression, it is not. Okay, we are looking for which are not in GPs. Okay, second one, 1, 4, 9, 16. Okay, initial term is 1. Okay, a2 by a1 equal to 4, but whereas a3 by a2 you can see 9 by 4, which is 2.25, which means the ratio is not constant, which means this is not in geometric progression, this series is not in geometric progression. Okay, so this is fine. Next, find which of the following are not geometric progression. So again same thing, right? Third part, 1 minus 1, 1 minus 1 and dash, so on. Okay, so from if you look at this given series, it looks like it is a not in any progression, right? It looks like 1 minus 1, 1 minus 1, it's a repetition. But if you see here, initial term is 1 and common ratio is a2 by a1, which is minus 1, a3 by a2, which is minus 1, a4 by a3 minus 1. That means the ratio is basically is constant, and which is r is equal to minus 1. So this is basically in geometric progression. Okay, so you have to see so many such examples to know that which is in geometric progression, which are not in geometric progression. Okay, so it looks very odd, but yes, this is in geometric progression. Okay, now minus 4, minus 20, minus 100, minus 500. So I can see clearly here it is 5 times, right? 5 times, 5 times. So obviously it is not in, it is in geometric progression. Okay, common ratio is 5. Let's see some more real-time examples of geometric progression. Okay, the first one is a person writes a letter to 4 of his friends. He asks each one of them to copy the letter and give it to 4 different persons with the same instructions, so they can also move the chain ahead similarly. Okay, so assuming that the chain is not broken, the number of letters at first, second, third stages. Okay, so first is a equal to 1. Okay, a person wrote 1 letter first. Okay, then he actually wrote, one person wrote 4 letters, right? So 4 letters, then 4 of them wrote 4 each, so 16 letters, then 4 times 64, then 256, right? So every term is basically multiplied by 4 to get the next term. So this is in geometric progression. Okay, so this is basically a classic example of a how your email account gets spammed. Okay, the spam mails, how they basically gets distributed, are the most famous cheating case who follow the pyramid cheating scheme, right? So these are all basically examples of this geometric progression. So this is a very good example. You have to understand the power of geometric progression. If you see here, the number of terms are 5 and you already have 256 letters went out. Okay, and if you actually sum up all this, they will become almost 1 less than twice, that is 511 actually. Okay, so which means the next, suppose this is 5 levels, sixth level is 1024, that is 1k, then 4k, 16k. So you can see how quickly it's getting spammed. The mailboxes getting spammed. Or in the pyramid structure, the pyramid is base is increasing so fast, that the person on the top, if he escape, he will make so much money actually. Okay, the very very famous cheating, which even today happens, pyramid scheme it's called. You can learn it online. You will definitely encounter by some person in your life, and you have to, at that time you have to understand this pyramid scheme. Okay, next. The total number, the total amount at the end of first, second, third year, if 500 is deposited in the bank with the annual interest of 10% compounded annually. Okay. So first year obviously I'll get 50 rupees interest. So the total will be 550. Then next year I get 10% interest on 550. So that is 2 years, right? That is 605. Okay, so if you see here, every year I am basically adding 10% extra, so 1.1 times basically this is. Okay, so 1.1 times, if I add, 10% is nothing but 10% interest, so my principal is 100, 10 is interest, so 110 by 100, which is 1.1. So each number is 1.1 times the previous number, right? So this is also in geometric progression. Okay, now the next one, a square is drawn by joining the midpoints of the sides. Okay, this is a square, you took the midpoints and draw another square, then took the midpoints and draw another square. Okay, and if the first one is 16 centimeters, then the area of the first, second, third, and so on. Okay, if this is 16, the area is 16 into 16, which is 256. Okay, and what will be this length? Okay, so obviously you will apply Pythagoras theorem, right? So 8, 8. Okay, so this will be 8 root 2, correct? So 8 root 2 into 8 root 2, 64 into 2, which is 128. Okay, and this will be again, okay, 4 root 2 into 4 root 2, that is 64. So each square area will be basically 1 by 2 of the previous one. So 1 by 2 is the common ratio here. So this is in geometric progression. Okay, initially a pendulum swings through an arc of 18 centimeters. Okay, from the distance from here to here is 18 centimeters. On each successive swings, the length of the arc is 1.9 part of the previous length. Okay, so if the first one is 18 into 0.9, so 16.2 into 0.9, 14.58 into 0.9, 13.122. So like this it will grow basically. Okay, so this is definitely in a geometric progression. Okay, for a good clock basically this will become 1. For a good clock this is 1, that means there is no loss of swing. Okay, so explain why each of the list above is a GP. Okay, so and next question is, to know about a GP, what is the minimum information that we need? Actually the answer to these both questions is same basically. Okay, if you see all these lists here, each one has an initial term which is not equal to 0, correct? And you have a common ratio of successive terms is always constant, which is R. Okay, so there is a ratio which is not equal to 1, correct? So these are the two minimum things you require to tell, and R should not be equal to 0, or should not be equal to 1. Okay, both are both holds actually. So that's why these are the two minimum conditions that we require for a GP. Okay, geometric progression. Okay, let's do some examples now. Write a GP if the first term is 3 and the common ratio is 2. Okay, this is a very basic question. We know that first term is multiplied by ratios to get the second term. So second term is AR equal to 3 into 2, that is 6. Next, second term, third term is basically 12, and the GP will go on like this. Okay, 3 comma 6 comma 12 comma 24, like this. Okay, so if you are given A, if you are given R, you can construct a geometric progression, right? So again here A is given, R is given, so obviously we can construct a geometric progression, A comma AR comma AR square, AR cube, etc. So 256 Okay, next term is 256 into minus half. Okay, and so on basically. So the values, final values will be 256 minus 128, 64 minus 32 and so on. Okay, because of this negative term basically every alternate term will become minus. Okay, now find the common ratio of the GP. So here we are trying to find the common ratio of this one. Okay, if you know that the given series is already in geometric progression, you just need to check only two terms. You can take two consecutive terms and check the ratio. That's enough. Okay, so in this case he is checking both. Okay, that is a2 by a1 which is minus 5 by 25. Okay, or a3 by a2 which is 1 by minus 5. Okay, both ways it is the common ratio is uh, minus 1 by 5. Okay, this is the common ratio. Okay, another example, which of the following list of numbers form a GP? Okay, here you have to check the common ratio to confirm whether they form a geometric progression or not. Okay, so if you take the first one, obviously you can see the solution below, but you can easily do the calculation here. 6 by 3 is 2, 12 by 6 is 2, so that means common ratio is 2, right, which is constant. So this is in geometric progression. This forms a geometric progression. Okay, now here minus 32 by 64 which is minus 1 by 2, 16 by minus 32 again minus 1 by 2, so this is also forms an geometric progression. Okay, and in this case 1 by 32 divided by 1 by 64 which means 2. Okay, and 1 by 8 by 1 by 32 which is actually 4. Okay, so here common ratio is not fixed. Okay, the common ratio is varying. First time it is 2, here it is 4. Okay, so this is not in geometric progression. Third one is not in geometric progression. Okay, so I think same thing is described here detailed. You can check it. Okay, now let's go to the exercise 6.4. Okay, exercise 6.4. In which of the following situations does the list numbers involved in the form of GP? Okay, geometric progression. Okay, the first one is salary of Sharmila. When her salary is 5 lakhs for the first year and expected to receive yearly increment of 10%. Okay, so let's see. First year salary which is A1 equal to 5 lakhs. Second year will be with a simple interest of, you can calculate, because every year you are calculating interest on the total amount, right, total salary. Okay, so 10% of this one is PTR by 100 interest part plus 5 lakhs, or you can use the compound interest formula, you will directly get the total. Okay, so that is 5 lakhs 50,000, and third year is 6 lakhs 5,000. So the three numbers which we see is 5 lakhs, 5 lakhs 50,000 and 6 lakhs 5,000. So if you check the common ratio, okay, each one has 11 by 10, 11 by 10, which is common ratio, right? The common ratio is 11 by 10 or 1.1. Okay, so this is definitely forms a geometric progression. Okay, next. Number of bricks needed to make each step. If the staircase has total 30 steps, provided that bottom step needs 100 bricks and each successive step needs 10 bricks less than the previous one. Okay, it's like a pyramid basically, or a triangle. The bottom one requires 100, that means A1 equal to 100. Okay, and number of bricks in second step is 98, that is A2. A3 is 96 and so on. Okay, 30 times basically. If you see here, definitely this is not in geometric progression because there is only minus 2 from the previous term. Okay, you take a term basically 100, minus 2 is 98, minus 2 is 96 and so on. So this is actually in arithmetic progression. Okay, just to confirm that, you take the GP. Okay, 98 by 100 for the first one, and second one is 48 by 49. Okay, so they are not, the ratios are not equal, so they are not in geometric progression. They don't form a geometric progression basically. All right, next, third one. perimeter of the each triangle when the midpoints of the sides of equilateral triangle whose side is 24 centimeters. Okay, let's see the picture here. The side is 24 centimeters. Okay, and the midpoints are joined basically. Okay, to form another triangle, and hence another triangle inside, another triangle inside, and so on. Okay, so the question is the perimeter of the triangle, whether they form a geometric progression. Okay, obviously let's check. The second one basically, from the triangle rule we know that if you join two midpoints of a triangle, sides of a triangle, then it is parallel to the third side. Okay, so this is DE is parallel to BC, and DE also half of BC. Okay, so which means DE is 12. Okay, so the inside triangle is basically 12 centimeter side. Okay, so if you take the perimeter of the top triangle, it is 3 into 24. Second triangle 3 into 12. Third triangle is 3 into 6, and so on. Okay, so the series formed is 72, 36, 18, and so on. So this is obviously forms a geometric progression because the common ratio is 1 by 2. Okay, next. Okay, write the three terms of the GP when the first term A and common ratio R are given. Okay, so this is very simple. A is I will just look at the one of them, but other three you can do yourself. A equal to 4, R equal to 3. So first three terms are A, AR, AR square, right? So 4, 12, and 36. Okay, so you do the similarly the other ones. Okay, next. Which of the following are in GP? If they are in GP, write the next three terms basically. Okay, 4, 18, 16, and dash dash dash. Okay, so if you see first, how do you confirm if it is in GP or not? Only way is common ratio, right? So check the common ratio. 8 by 4 equal to 2, 16 by 8 equal to 2. So the ratio is fixed, and the common ratio is R equal to 2. Okay, so this series is in geometric progression. So the next three terms are basically from 16 onwards. 16 into common ratio, 16R, 16R square, 16R cube. Okay, that is 32, 64, and 128. Okay, next. 1 by 3 minus 1 by 6, 1 by 12, and dash dash dash. So common ratios, if you see, 1 by 6 divided by 1 by 3, that it will become reciprocal, right? 3 by 1. So which is equal to minus 1 by 2. 1 by 12 divided by minus 1 by 6, which is also minus 1 by 2. So the common ratio is minus 1 by 2. Hence the next three terms are basically minus 24, minus 1 by 24, 1 by 48, and minus 1 by 96. Next. 5, 55, 555, and so on. Okay. Common ratio is 55 by 5 is 11, 555 by 55 is 111 by 11. Okay, this ratio is not same. Since ratio is not same, they don't form any geometric progression. Next, minus 2, minus 6, minus 18, and so on. Okay, so check the common ratio. Minus 6 by minus 2 is 3, minus 18 by minus 6 is also 3. So common ratio is 3. So the next three terms are minus 54, minus 162, minus 486. Okay, next. Okay, 1 by 2, 1 by 4, 1 by 6. If you see, the common ratio is, first one is 1 by 4 divided by 1 by 2, which is 1 by 2. 1 by 6 divided by 1 by 4 is 2 by 3. Okay, so since the ratios are not same, they don't form any geometric progression. 3 minus 3 square, 3 cube, and so on. Okay, so here the common ratio is minus 3 square by 3, which is minus 3. 3 cube by minus 3 square, which is minus 3. So common ratio is minus 3. So next three terms are basically minus 3 power 4, 3 power 5, and minus 3 power 6. Okay, just be careful when you have a negative sign in the geometric progression. That means mostly alternate terms will become negative. Okay, so just be careful about it. Okay, x 1, 1 by x, and so on. So the common ratio is 1 by x, we can clearly see. Here it is 1 by x, 1 by x by 1, which is 1 by x. Okay, common ratio is 1 by x. So it is in geometric progression, and next three terms are 1 by x square, 1 by x cube, 1 by x power 4. Okay, this also same, you can check. Okay, so this is also same, 0.4, 0.04, 0.004. Okay, so 0.1 is the common ratio. So the next three terms are given here. Okay, the fourth problem. Find x so that x plus 2 and x plus 6 are consecutive terms of a geometric progression. Okay, these three are consecutive terms of a geometric progression. We should find x. Okay, so we know if these three are consecutive terms, we know that the common ratios are same. Okay, if ABC are in GP, basically B by A equal to C by B. That means B square equal to AC or B equal to square root of AC, right? One of it is true. So let's choose B square equal to AC. So that means x plus 2 whole square equal to x into x plus 6, which means x square plus 4x plus 4 equal to x square plus 6x. If you simplify, you will get x equal to 2. Okay, so yeah, sorry. So x equal to 6, x equal to 2. So this is the answer. If you want, you can write the series. Basically, it will become 2, 4 and 8. Okay, 2, 4 and 8. The common ratio is 2, obviously. Okay, so let's see the next section, that is nth term of a geometric progression. Let us determine the nth term of a geometric progression. Okay, we'll take example. The number of bacteria in a certain petri dish culture triples every hour. Okay, the bacteria triples every hour. If there are 30 bacteria present in the petri dish originally, then what would be the number of bacteria in the fourth hour? Okay, so we know how to do this. Every time it is triples, right? Every hour. So second hour it will be 3 times the number of bacteria in the first hour. That is 3 into 30, which is, we can also write it as 30 into 3 power 1. Okay, or since you want to have a relation with second hour, so you can call it 3 to the power of 2 minus 1. Okay, that is 90. Okay, now in the third hour, basically 3 into number of bacteria in the second hour, that is 3 into 90, or you can also rewrite this as 30 into 3 into 3, or you want to have a relation with third hour, so okay, so you can write it as 30 into 3 power 3 minus 1, okay, which is 270. And in the fourth hour, it will be 3 times the previous one, that is 3 into 270, which you can write as 30 into 3 into 3 into 3, or we are relating with fourth hour, so it will be 30 times 3 to the power of 4 minus 1. Okay, so we can see the numbers here. Okay, the next 4 hours, the 4 hours, how much the bacteria count will be. Okay, obviously these are in GP because common ratio is 3 actually. So if you want to check what is the amount of bacteria in 20th hour, what you will do, basically 30 times. Okay, because we are looking at 20, so 30 times 3 to the power of 20 minus 1. Okay, that is 3 to the power of 19. So 30 times 3 to the power of 19, this is the number of bacteria in the 20th hour. Okay, so from this we can easily derive a general equation for the nth term of a geometric progression. If a1 is the initial term or first term, then the second term is basically a into r to the power of 2 minus 1. Third term is a into r to the power of 3 minus 1. Fourth term is a into r to the power of 4 minus 1, and so on. So general term is a to the power of n. An is basically a into r to the power of n minus 1. Okay, an, okay, that is nth term is equal to a into r to the power of n minus 1. Okay, so this is the general term of a geometric progression. Okay, so just like how we have for the arithmetic progression a plus n minus 1 into d, here it is a into r to the power of n minus 1. Okay, now let's see some examples. Okay, find the 20th and nth term of a GP. Okay, of this one given here 5 by 2, 5 by 4, 5 by 8, etc. Here a equal to 5 by 2, common ratio is 5 by 4 by 5 by 2, which is 1 by 2. Okay, so you have a, you have r. Okay, now we are trying to find nth term, right? 20th term basically. Okay, a20 is equal to a20 is equal to a into r to the power of 20 minus 1. So that is 5 by 2, which is the initial term, right? 5 by 2 is the initial term into 1 by 2 whole to the power of 19. Okay, that means 5 by 2 to the power of 20. Okay, this is the 20th term, and general term is basically a n equal to 5 by 2 to the power of n. This is the general term. Okay, so next, which term of the GP 2 comma 2 square 2 square root of 2 comma 4 is 128. So 128 is which term of this given geometric progression? This is another type of question which you can see. A n is given basically. Okay, so a n equal to a into r to the power of n minus 1, which is equal to 128, and we know a is 2 and r is common ratio, which is square root of 2. So 2 into square root of 2 whole to the power of n minus 1 equal to 128. If you simplify, what you will get is n minus 1 by 2 equal to 6 or n equal to 13. Okay, so 13th term is 128 in the given geometric progression. So this is another type of problem. Okay, another type of problems which you can see is in a geometric progression, third term and 24th term, third term is 24 and sixth term is 192. Find the 10th term. Okay, so a3 is given, a6 is given. a3 is nothing but ar square, a6 is ar power 5, which is, okay, the values are given here. So if you divide them, you will get r directly, right? So r cube equal to 8 or r equal to 2. Now once you know r, you can substitute any of these values and get the a value, correct? So if you substitute in the first equation, you get a as 6. Okay, once you know a and r, you can derive any term, right? So 10th term is a r to the power of 9, okay, which is nothing but 3072. Okay, so let's do the exercise section for this one. Yeah, let's do the exercise 6.5 in the geometric progression part. Okay, for each geometric progression given below, find the common ratio r and the term basically. Okay, nth term. So 3 by 2, 3 by 4, 3 by 8. Obviously, first thing we should do is find the common ratio. So a1 is 3. Common ratio is you take any two terms. So here I took 2 and 1. a2 by a1 is 3 by 2 into 1 by 3, which is 1 by 2. So common ratio is 1 by 2. So nth term is a r to the power of n minus 1. So which is equal to 3 into 1 by 2 whole to the power of n minus 1. This is the nth term. Or you can, if you can ignore 1, it will become 3 divided by 2 to the power of n minus 1. Okay, next 2 minus 6, 18 minus 54. So initial term is 2. Common ratio is minus 6 by 2, which is minus 3. So nth term is 2 into minus 3 to the power of n minus 1. Okay, so here the term will become minus negative or positive depending on the value of n basically. Okay, next. Okay, minus 1, minus 3, minus 9, minus 27. This is, yeah, simple. A 1 is minus 1 and common ratio is 3. So this is the nth term. So similarly, you just check for other questions in this way. The template is same. Basically, you will find the common ratio and substitute the values in a r to the power of n minus 1. A times r to the power of n minus 1. Okay. Find the 10th and nth term of GP, which is given here. Okay. Initial term is a1 equal to 5 and common ratio is 5. Okay, so nth term is a r to the power of n minus 1, which is 5 into 5 to the power of n minus 1 or 5 to the power of n. Okay, so 10th term will become a r power 9, which is 5 to the power of 10. Okay, find the indicator term of each geometric progression here. Okay, so a equal to 9, a and r are given. Basically initial term and common ratio are given. You need to find a7. So a7 is nothing but r to the power of 6, right? A r to the power of 6. So 9 into 1 by 3 to the power of 6, that is 1 by 81. Okay, similarly next one you can do it yourself. Okay, that's the answer. Okay, which term of the AP, which term of the GP 2 comma 8 comma 32 is 512. So basically what we need to find is an is given, an is 512. You need to find what is the n. Okay, so a equal to or a1 equal to 2, common ratio is 4, r equal to 4. Okay, now nth term a r to the power of n minus 1 equal to 512. So a and r values you substitute 2 into 4 to the power of n minus 1. So what you will get is basically 2 to the power of 2n minus 1 equal to 2 to the power of 9, which means 2n minus 1 equal to 9 or n equal to 5. Okay, so 512 is the fifth term basically. Okay, next, square root of 3 square root of 3 is 729. So an is 729 in this case. Okay, and common ratio is square root of 3, initial term also square root of 3. So if you substitute all the values, what you will get is n minus 1 by 2 equal to 6. Okay, or n equal to 13. So 729 is the 13th term. Okay, next, 1 by 3, 1 by 9, 1 by 27 is the GP. Okay, so 1 by 2187 is which term? That we need to find out. So a1 equal to 1 by 3, common ratio is 1 by 3. So if I substitute basically nth term, okay, 1 by 2187 equal to 1 by 3 whole to the power of n, or 3 to the power of 7 basically. Okay, 2087 you can write it as 3 to the power of 7. So n equal to 7. Okay, so seventh term is 1 by 2187. Find the 12th term of GP whose 8th term is 192 and common ratio is 2. Okay, we have to find the 12th term. Okay, 8th term is given and common ratio is given. So once 8th term is given, you know a8 equal to a r to the power of 7, which is 192. Okay, and common ratio is 2, so 2 to the power of 7, that is. So from this you can get a value. A is equal to 3 by 2. You have the a and r. Now any term you can find out. Okay, a12 is a r to the power of 11. So it is 3 by 2 into 2 to the power of 11, which is 3072. a12 is 3072. Next, the fourth term of a geometric progression is 2 by 3, and the seventh term is given here 16 by 81. Okay, find the geometric progression. So a4 is given, a7 is given. We should find the common ratio and a, then we can write the geometric progression, right? So if I basically divide these two, I will get r square, correct? R cube I will get. So r cube is equal to 8 by 27, which is 2 by 3 whole to the power of 3 I can write. So r is equal to, common ratio is 2 by 3. I can substitute in one of the equations here. So a4 equal to r cube, which is equal to a into 2 by 3 whole cube equal to 2 by 3, which means a is 9 by 4. Okay, so now you have a, you have r. So the GP is 9 by 4, 3 by 2, 1, 2 by 3, and so on. Okay, next. Okay, if the geometric progressions, two geometric progressions are given, okay, and their nth terms are equal, the question here is these two geometric progression nth terms are equal, find the value of n. Which term of these two geometric progressions is same? Okay, so let's assume the nth term of both geometric progressions is same. So for the first term, first geometric progression, a is equal to 162, r is 1 by 3, and for the second geometric progression, a is 2 by 81 and r is 3. Okay, so we have to just equate nth term of both these geometric progressions. Okay, so 162 into 1 by 3 whole power n minus 1 is equal to 2 by 81 into 3 to the power of n minus 1. Okay, so this implies if you take 3 to the power of n minus 1 to the other side and constant to this side, it will become 3 to the power of 2n minus 2 equal to 81 to the power of 2 or 81 square, 3 to the power of 8, that is. Okay, so 2 to the power of 2n minus 2 is equal to 8 or n is equal to 5. Okay, so fifth term of both the series is same, which is I am writing here 162 into 1 by 3 whole to the power of 5. It should be 4. Okay, 5 minus 1, right? So it should be 4. Okay, next. So just recalculate this value. Value is not correct. Okay, let's do the optional exercise now. Yeah, first one is which term of the AP 121, 117, 113 is first negative term. Okay, so just remember this is optional exercise for the whole progressions. That means you will have problems from both AP arithmetic progression as well as geometric progression. Okay, the question here is arithmetic progression is given here. It is a reducing arithmetic progression, if you see. Okay, minus 4 is the common difference, right? So the question is what is the first negative term of this one? Okay, so how do you define a negative term? For this AP, first thing is a equal to 121, d is equal to minus 4. Okay, an should be less than 0, right? So we need to find n such that that should be just less than 0. Okay, closest basically. Okay, so an is nothing but a plus n minus 1 into d. So that is 121 plus n minus 1 into minus 4, which is less than 0. Okay, so n should be, if you simplify this, n should be greater than 121 by 4 plus 1, that is n should be greater than 31.25. So that means n should be the 32nd term. Okay, n is 32, which is the first negative term. Okay, 32nd term is the first negative term of this AP. Next, the sum of the third and the seventh terms of AP is 6. Okay, their product is 8. Find the sum of first 16 terms of the AP. Okay, what is given? A3 into A7, A3 plus A7 is 6. A3 plus A7 is 6. Okay, that is nothing but 2A plus 8D. Okay, 2A plus 8D equal to 6, which is a plus 4d equal to 3, and also a plus 2d into a plus 6d equal to 8. Product is 8, that is given, right? So if you simplify this, basically what you will get is 3 minus 2d into 3 plus 2d equal to 8. I am just substituting the a value basically with this 3 minus 4d here. Okay, that way it is easy. So I got the d value, d is plus or minus half basically. Okay, so for d equal to half, a1 is 1 basically. Okay, I can take any of this equation and substitute, right? D equal to minus of. Okay, and S16 is basically 76 for d equal to half. D equal to minus half, S16 is 4. Okay, so these are the two possible values for the, and obviously you will get two different arithmetic progressions for this problem. Okay, next. Okay, a ladder has rungs 25 centimeters apart. So between the rungs, the distance is 25 centimeters. Okay, and from the bottommost rung to the topmost, it is 2.5 meters. Okay, that is the data given from the picture. You can clearly see that, and the rungs are actually, the length of the bottommost rung is 45 and topmost is 25 centimeters. Okay, the question is, what is the length of the wood required for the rungs? That means sum of all this, sum of all this. So if you uh, make a series of these rungs length actually, okay, and prove that they are in arithmetic progression, okay, then the total length of the rungs is nothing but the sum of the arithmetic progression of n terms, whatever is number of rungs here, right? So first thing is we should find out n, how many rungs are there. So that is simple. 2.5 meters is total, and each one is separated by 25 centimeters, correct? So rungs are 25 centimeters apart, which means in 2.5 meters we can have 250 centimeters by 25 centimeters plus 1, because both sides inclusive, right? Two sides inclusive, so it will have total 11 rungs. So n is equal to 11. Okay. Now first rung is 45 centimeters, n is equal to 11. Okay, and L also we have. Okay, we don't require the D now. Common difference is not required, because for a sum of arithmetic progression of n terms, we just need first and last terms and n. That is enough. So n by 2 into 2a plus L. Sorry. Oh, sorry. This is a wrong value here. N by 2 into a plus L, basically. That's the value. Okay. So here it will become 11 by 2 into 45 plus 25. So 70. Okay, the answer is not this one. You can calculate. The answer is 35 into 11. Okay, 35 into 11. That is 350 plus 35. 385 is the answer. Okay, this is wrong. Okay, so this is wrong. This is wrong. So it will become 70. 35 into 11. 35 into 11 is 385. 385. 35 into 11. 350 plus 35, which is 385 centimeters. Okay, this is the correct answer. Okay, next. The houses of a row are numbered consecutively from 1 to 49. Okay. Okay, 1 to 45. Show that there is a value of x such that sum of the numbers of the houses preceding the house numbered x are equal to the sum of the uh, numbers of the houses following it, which means let's take 1 to 49. There is some number x in between, where the sum of the previous terms is equal to sum of the succeeding terms after that x. Okay, and what is the value of x? That's what we need to find. Okay, so let's see. Okay, so a1 equal to 1, d1 is 1, because numbers are basically continuous numbers 1 to 49. So s of x minus 1 is equal to, correct, up to x minus 1 is nothing but s of 49 minus s of x, correct. If you remove this, you will get s of x minus 1. Okay, so x minus 1 by 2, that is preceding, right? X minus 1 by 2 into 2a plus x minus 1 minus 1d equal to 49 by 2 into 2a plus 48d minus x by 2 into 2a plus x minus 1d. Okay, so once you have this equation here, you just solve it for x. Okay, so the value you will get for x is basically 35. Okay, which means x equal to, sorry, x is equal to 35, and s34 is what we need to calculate, right? S34 is basically this one is the value given here. Okay, I think they did not ask x is basically 35. That's enough actually. Okay, they didn't ask for this value. Okay, next. Okay, the sitting area around a football ground comprises of 15 steps. If you see here, there are 15 steps here, as shown here. Each step has a rise of 1/4. Okay, so this height is 1 by 4 increment for each step. Okay, and the tread of 1 by 2 meters. Okay, this is 1 by 2 meters. Okay, 1 by 4 meter of the height, 1 by 2 meters of the width for the uh, step. Okay, calculate the total volume of the sitting area. Okay, basically we should calculate total volume of this step block, whatever you call. Okay, and the width is, the length of the step is 50 meters. Okay, so we know we can calculate step by step actually, and they will form a progression, then calculate the sum of it. Okay, so the height of the first step is 1 by 4 meters. Okay, next height of the second step is half meter, 1 by 4 plus 1 by 4. Third step is 3 by 4. Okay, so the height of the each step is increased by 1 by 4 meters. Okay, and length is 50 meters and width is same for each step. Correct, that is half meter. So that means volume of first cuboid, first step, if I come calculate the volume of first step, that is length into breadth into height, which is equal to 50 into half into 1 by 4, that is 6.25 meter cube. Volume of second step is 50 into half, which is 12.50 meter cube this is. Okay, and third one is basically 18.75 meter cube. Okay, so this is forming a arithmetic progression, right? 6.25 difference, correct? So first term is 6.25, common difference is 6.25. Okay, now we need to find out total volume, total of this one for 15 steps. So n is equal to 15. So Sn equal to S15, which is equal to 15 by 2 into 2 into 6.25 plus 15 minus 1 into 6.25. Okay, so the total you will get is basically around 750 meter cube. Okay, this is the volume of the block given there. Next. Okay, 150 workers are engaged to finish a piece of work in a certain number of days. Okay, if 4 workers are dropped from the work on second day and 4 workers dropped on the third day and so on, it took 8 more days to finish the work. Find the number of days in which the work was completed. Okay, so let's say 150 workers will finish the work in X number of days. Okay, this is actually they can finish in X number of days, but it took X plus 8 days because 4 people are dropping every day. Okay, so it is given that 150 times X, 150X, because X number of days they worked, 150 workers, right? So 150X is the total work. Total work is equal to 150 into 1 plus 146 into 1 plus 142 into 1, like that up to X plus 8 terms, right? Because they worked 8 days more actually, so X plus 8 days. Okay, so now for this AP, A equal to 150, D is equal to -4, N is X plus 8, Sn is 150X. So you substitute all the values, what you will get is 150X equal to X plus 8 by 2 into 2 into 150 plus X plus 8 minus 1 into -4. If you simplify, what you will get is X minus 17, you will get a quadratic equation. You solve it, basically you get X equal to 17 or X equal to -32. Definitely number of days cannot be negative, so X equal to 17. That means the total number of days to finish the work in reducing workers. Okay, if you reduce, normally they can finish in 17 days, but this time because every day 4 people are reducing, they took 25 days. Okay, that is 17 plus 8, 25 days. That's the answer. Next. A machine costs rupees 5 lakhs. If its value depreciates 15% on the first year and so on basically. Okay, whatever data is given here you can see. Okay, what will be its value at the end of 10 years? Okay, so percentage of the depreciation in each year is 15%, 13 and a half, 12%, and so on. So let's see if this is in any progression. Okay, so 15, 13 and a half, 12. So this is definitely in a 1.5, 3 by 2, right? Yeah, 3 by minus 3 by 2 is the common difference. So total depreciation at the end of 10 years is 10 by 2 into 2 into 15 plus 10 minus 1 into minus 3 by 2. Minus 3 by 2 is the common difference. Okay, so which is equal to 165 by 2 or 82 and a half. Okay, so after 10 years the machine cost is basically 100 minus 82.5. This much percentage is depreciation. So machine cost is basically 100 minus 82.5, okay, into 5 lakhs by 100, that is 87,500. This is the cost of the machine at the end of 10 years. Okay, hope you understand all these problems. These are these concepts of progressions is very useful in later when you get the series. Actually, you will get the series problems, number series. That time when you want to calculate the general formula for each series, these concepts will help you a lot. Okay, that mostly that will come in your 11th and 12th. These are the basics. Okay, so one thing missing in the 10th class Telangana textbook is the sum of geometric progression, which is not given actually. So I just want to touch on this one because this will make you completion of this arithmetic and geometric progression. So you can actually attempt all the Olympiad questions based on this additional one concept. So I don't give too many examples. I'll just give only one examples, but you can actually form plenty of examples using these arithmetic and geometric progression sums. Okay. So in a arithmetic progression, the Sn sum is equal to a plus ar plus ar square plus ar cube, right? So this also you can actually do same way as sum of arithmetic progression problem. You can solve this also very easy. Okay. So Sn equal to a times r to the power of n minus 1 divided by r minus 1 if r is greater than 1. Okay. So most important thing to know is you have two equations for the sum of geometric progression depending on what is the value of r. If r is greater than 1, you have one equation. If r is less than 1, you have another equation, which is a into 1 minus r to the power of n divided by 1 minus r. Okay, so remember this, you have to apply depending on what is the value of r. Okay, so one example I gave here, if sum of 3, 6, 12, 24, 10 times. Okay, so here a equal to 3, r equal to 2, n equal to minus 10. So Sn is, I will choose this equation because it is greater than 1, r is greater than 1. So S10 equal to 3 into 2 to the power of 10 minus 1 by 2 minus 1, which is equal to 3069. Okay. So yeah, with this we completed the geometric progression part. Okay. Let's see the summary what we have discussed actually. Okay. The terms of APR arithmetic progression are a comma a plus d, a plus 2d, a plus 3d, and so on. Okay. The difference of consecutive terms in a AP is always constant. So AK plus 1 minus AK is same for all different values of K. Okay, this is most important. In an AP, nth term is denoted by A of n equal to A plus n minus 1 into D. Okay, the sum of n terms of AP is, the sum of n terms of AP is S equal to n by 2 into 2A plus n minus 1 into D. Okay, this is one equation where you don't know the last term. Okay, this is purely based on n, A and D. Okay, if you don't know the common difference, then other way of summing up is S equal to n by 2 into A plus L. L is the last term. Okay, you don't know the common difference, but you know the first term, last term, and n. Then this is the equation. Okay, so these are all very simple, right? You just have 2 3 equations here, only 3 equations here and 3 equations in GB. That's it. Okay, the general form of geometric progression is ar square, ar cube, and so on. The common difference is always same basically, which is r. Okay, so the nth term formula is a of n equal to a of r to the power of n minus 1. Okay, and the sum of arithmetic progression terms is equal to there are two equations, s of n equal to a into r n, okay, r to the power of n minus 1 divided by r minus 1 if r is greater than 1. Okay, sum is equal to sum of geometric progression terms is equal to a into 1 minus r to the power of n divided by 1 minus r if r is less than 1. Okay, so these are the all the formulas and equations which we learnt and solved different kinds of problems. Okay, so yeah, that's all here, and I will be doing more problems on the Olympiad progression problems. Please look at those videos also. I will not cover the theory. Theory is this is the theory. This is enough to solve any Olympiad problem for the progressions. Thank you.